What is instantaneous rate of change? The rate of change of a particular moment. The formula is y2 minus y1 over x2 minus x1. Remember, use small increments of time. The smaller the increment, the more accurate the rate. Linear functions.
A flight of an airplane trip from New York to Los Angeles usually follows a plan based on computer weather information and is monitored by onboard computer flight control technology. Suppose that in one such flight plan, the distance traveled will be a function of time in flight with the rule d of t equals 525 t, time in hours and distance in miles. For letter A, it says, based on this flight plan function, what is the intended average speed for the trip? For A, we took points 2 and 1, and their distances, or their speed, and used our y2 minus y1 over x2 minus x1, and then divided those numbers to get 525 miles per hour. For B, how fast will the plane be traveling 1 hour, 2.5 hours, and 4.25 hours after takeoff? For these, we did the same thing, using our y2 minus y1 over x2 minus x1, and then dividing those two numbers, we came up with our answers. 1 hour, 525, 2.5, 525, and 4.5, 525. For C, how are your answers to parts A and B shown in tables and graphs of time, distance, pairs for the given flight plan function? For this, we just put it in a graph to show the comparison of the numbers. Quadratic functions. One of the most spectacular high diving events in Mexico where cliff divers drops off rocky outcroppings into ocean bays. If one of these divers drops from a spot that is 30 meters above water, his height will be modeled well by a function with rule h of t equals 30 minus 4.9 t to the second power. For A, how long will it take the diver to reach the surface of the water? Using our calculator, we found that it takes about 2.5 seconds for the diver to reach the surface. For B, what will be the diver's average velocity from takeoff to hitting the water? What will his average speed be? Again, we plotted our points in a table and then used two different points and used our y2 minus y1 over x2 minus x1, divided those numbers and found that it was negative 9.8 meters per second. This negative means that the diver was dropping. For C, how will the diver's speed change during his flight? How is that change shown in the shape of the graph? The diver's speed will increase as he falls. This is shown in the graph because as time passes, the slope becomes steeper.